This is page 1 of the Sequences and Series review. We're given that the fourth term of an arithmetic sequence is 17. So I'm going to write 17 is going to be the first term, I don't know what that is yet, plus the common difference, I don't know what that is either, times n minus 1. It's the fourth term, so I will say n minus 1 is 3. The 12th term is 49, the same process. A12, which is 49, equals A1, the first term, plus some common difference, times now the 12th term. So n is 12, n minus 1 is 11. I can figure out what the first term is if I subtract. I'm actually going to subtract the top from the bottom just so I stick with positive numbers. 49 minus 17 gets me 32. A1 minus A1 cancels out. 11D minus 3D gets me 8D. If I divide now both sides by 4, I get that D equals, or divide both sides by 8, I get D equals 4. Now, with D being 4, I can just plug it back in. Say to the first one, 17 equals the first term, plus the common difference times 3 is 4 times 3 is 12. Subtract 12 from both sides, I get 5 equals A1. There's my first term. I need to find the sum of the first 20 terms. Well, the sum of the first 20 terms is going to be the first term, 5, plus the 20th term. I don't really know what that is yet, so I'll leave that blank, times the number of terms. There's 20 divided by 2. Now the 20th term, if I want to figure it out, I can say A20 is just going to be, well, plugging back into my first formula, the first term, 5, plus the common difference, 4, times 20 minus 1 is 19. 5 times plus 4 times 19 comes out to be 81. So I put that in here. Now the sum formula, 81 plus 5 times 20 divided by 2 gets me 860. And that's the sum of the first 20 terms. The key here, know your nth term of an arithmetic sum and know the sum of the first n terms. In a geometric sequence, if A3 is 50 and A6 is 6,250, find the sum of the first 8 terms. It's the same thing that we did before, but now we're figuring out another sum. So, for a geometric sequence, the nth term equals the first term now times some common ratio to the nth power, n minus 1th power. So, for example, the third term being 50, well, that's the first term times the common ratio to the 3 minus 1 power is squared. The sixth term, being 6,250, is the first term times the common ratio to the 5th power. N minus 1 is 5 here. Now, in the last case, what we did was we subtracted them. In this case, what we're going to do is now divide the top over the bottom. Or just to make things easier, since we can divide either way, I'm going to divide it like this, I think. That way, I just end up with positive exponents and whole numbers, and everything is a lot nicer. So, 6,250 divided by 50 gets me 125. So I have 125 equals, well, a1 over a1 cancels out, and I have r to the 5th over r squared. Using our exponent rules, we subtract those, r cubed. When I take the cubed root of that, I get that the common ratio equals just 5. Now I can plug this back in to figure out what A1 is, but I can also just say, well, if A3 is 50, then I can divide by 5 to get that A2 equals 10, and I can divide that by 5 to get that A1 equals 2. So you have the first term is 2, the common ratio is 5. If you want to figure out the sum of the first 8 terms, we can say the sum of 8, well, that's going to be the first term, A1, times 1 minus the common ratio to the nth power, all over 1 minus the common ratio. Or in this case, 2 is A1, times 1 minus the common ratio is 5 to the 8th power, because there's 8 terms, all over 1 minus 5. Putting that into my calculator, 2 times 1 minus 5 to the, all the 8th power is just for the 5, divided by 1 minus 5, putting it in parentheses to not get a miscommunication. I end up with 195,312. 195,312. Okay, problem number 3. The first 9 terms of a geometric series that has a common ratio of 5 and a sum of 7,812,496. Okay, so in this case, R equals 5, S sub 9 equals 7,812,496. I need to give the first term of that. So I can plug this into my formula. The sum of the first 9 terms is 7,812,496. This equals, well, the first term times 1 minus the common ratio to the number of terms. In this case, there's 9 terms, all over 1 minus 5. If I multiply this over to both sides, I have 7,812,496 times 1 minus 5 is negative 4, and I multiply that over to the other side, and I divide by 1 minus 5 to the 9th. Plug this into your calculator, you should get your answer, just solving for A1. So 7,812,496 times negative 4 divided by 1 minus 5 to the power of 9 gets me 16. And I have a feeling that's the right answer, because the chance that I'd end up with a whole number with some big calculations like that is pretty low. Let's find the sum of this term. It looks to me like I'm subtracting 1,000 and then subtracting 800, so it's not going, it's switching from pluses to minuses, so it's not going to be arithmetic. I think I'm multiplying by something. So let's try and see what I'm multiplying by. 4,000 divided by, actually it's negative 4,000 divided by 5,000, negative 0.8. And then just to check, I'm going to try the next one also. 3,200 divided by negative 4,000. Negative 4,000 should end up with it. Still negative 0.8. So this isn't geometric sequence, or geometric series, since they're all added together. And I'm going through a long list. Now, I could figure out, the key here is I need to know what term is this. This is some term because I need to know, or do I even need to know the number of terms? No, I don't. I need the number of terms for the arithmetic one, or the n over here. But for the geometric, all I need is the first term right here, the common ratio, and that's what I have. The first term is 5,000. 1 minus the common ratio. Uh-oh, I do need the number of terms, because I need to the nth power. So let's figure out how many terms there are here. Rather than plugging it into the formula, I'm just going to start with 5,000 times negative 0.8, and I end up with negative 4,000. That's the second term, times negative 0.8. The third term is 3,200. I knew that. But now I can just press enter. The fourth term is 2,560. Fifth term, sixth, seventh, eighth. Oh, I need these to be fractions. Not there yet. Ninth. No, not there yet. 10th. There it is. And equals 10. So I'm going to raise this to the 10th power, all over 1 minus negative 0.8. Putting this into the calculator, just as is, 5,000 times 1 minus negative 0.8 to the power of 10, all divided by 1 minus negative 0.8 gets me 4,701. All right, a couple more problems. Let's figure out the sum of these. Well, this looks like a arithmetic sequence. I'm adding or subtracting 3 each time. But one thing to notice is I'm starting at k. So the first term is when k equals 2, or 2,000 minus 3 times 2. 2,000 minus 3 times 2 is 1,000. Whoa, 2,000. Minus 3 times 2 is 1,994. So that's the first term. The last term is 2,000 minus 3 times 37. Comes out to be 1,889. Now the number of terms is going to be 37 minus 2 plus 1, or 36 terms. Think if I started at 1, there'd be 37 terms. I'm starting at 2 though, so there's only 36 terms. So first term plus last term times the number of terms all over 2 comes out to be, let's see, 1994 times 1889, not times, plus 1889 times 36 divided by 2 gets me 69,894. Voila. For part B, this is an infinite sum. The infinite sum of a geometric series is just 1 over 1 minus r. Sorry, a1, the first term, over 1 minus r. So the first term in this case is 1/2, because it's going to be 1/2 to the 0th power. Would it be 1/2 to the 0th power? It would. Sorry, 1/2 to the 1 minus 1 is 0, so to the 0th power equals 1. The first term is 1. The common ratio equals 1/2, because I'm multiplying by 1/2 each time. So 1 over 1 minus 1/2 is equal to 2. That is the infinite sum of this geometric series.